Okay, purpose of this video is for you to analyze mass spec data, particularly mass spec data, elemental mass spec data. All right. First thing to consider is why. Well, this is one way to understand where this 24.305 comes from from a data perspective, and how they take data to turn it into this average atomic mass. All right, that's for the magnesium. That's 24. What's the data that comes up with this for this number? Here's some definition. Here's the definition, and this word natural, sometimes it's also known as relative, sometimes it's known as percent. Just like the average atomic mass is also known as the relative atomic mass, or sometimes as the atomic weight. All right, they're all kind of interchangeable. In the definition, that word abundance really means that something that this image is going to show you. You can see the image is lots of stars and only one pentagon. Therefore, the pentagon has a low percent abundance and the stars have a high percent abundance. And that's what percent abundance means. Now, this is a mass spectrometer, and this when we look at the data, what it generates about an element, what does it look like? All right. Well, the data is basically going to be kind of like a bar graph, and in its simplest form. And on the x-axis, you're going to have a mass to charge ratio, and on the y-axis, you're going to be somehow charting the amounts that you have. All right. It could be actually an actual amount, like a number comparison, like 3 to 1 or 3 to 2 or something like that. Now here's a graph, and what can I get from this data? All right, what can I get from this looking at it? Well, I can know it's got 5 isotopes. I can know their mass number. I also can know their percent abundance from it, and I can kind of figure out what's the most common isotope for this particular element. It's going to be this X50 because it's the largest bar. All right, the largest one is the highest. Now, the most common. So those 4 things again were its relative abundance, all right, percent abundance. I read that off the y-axis. I know its mass number. That's off the x-axis. I also know the number of isotopes, all right. I could also calculate if I wanted, if I knew the element, I could calculate the number of neutrons, right? Each would have different number of neutrons. This would have 1 more because I would subtract the atomic number from this, and that's what I'm going to be able to know. So here's what it identifies the isotopes. There you go. 2 things that aren't on this list were, like, you could calculate the number of neutrons by subtracting the atomic number, and you can figure out what's the most common one. Now, when I look at this graph, what's the data that I get? Here's the data, all right? Now, you wouldn't necessarily be able to get these exact numbers, but let's just say you had a machine that did this, which you would be able to read this from like a computer printout. How do I calculate the actual atomic mass, the average atomic mass from this graph? All right. Well, the first thing you need to consider is, what's my formula? And what it's going to need to do is weigh each one of these bars a little bit differently. All right. It's basically a weighted average, so it's going to weigh this one the most in the overall average. And the way to do that is by multiplying the individual mass by the percent. All right. And here's the formula. This is it in a simpler form. The 100 is because on the graph, this 51.15, you want that to be a decimal, and that's why you're dividing it by 100. You could just remember that and leave out the 100, all right? And if here's my data, here's just what's going to look like. I'm going to multiply each one of these factors by this percent abundance or its relative abundance as a decimal, and then it's like a big summation problem, all right? And that's what I would get for the element. Or no, not the element, but the element's average atomic mass. And there are my sources. All right. Hope this was helpful. Let me know if I can do anything to help you out. All right, bye.